So this particular problem says the following data was the current unemployment and inflation rate as of June 2016 of the top economic nations in the world, measured by GDP, gross domestic product. Okay, let's figure this out.
The inflation rate of the USA is relatively less. Can you fix inflation rate? Can we build another inflation rate?
Where'd you get this? All right. So, hey, what should we do with this?
Put it into Desmos.
Yay, put it into Desmos. Okay, does everyone know about this Desmos? So what is this you speak of, sir? All right, I got to mosey over here so I can see the data. All right, here we go. Everyone good? Everyone have this page out? So 17.9, 17, 11, 4.1, 3.4, 2.8, 2.8, 2.4, 2.1, 1.8, 1.8, 1.6, 1.4, 1.3. Where'd it go? The heck? Seventeen, 11, 4.1, 3.4, 2.8, 2.4, 2.1, 2.1, 1.8, 1.8, 1.6, 1.4, 1.3, 1.2, 1.2, 1.1. All right, boom, boom, boom. Someone do me a favor, read me down this inflation rate. I have 1.5. 1.5, what's next after 1.5? 2.6, next. 3.1, next. Do what? 0.1? And then 2? 1.7? 2.3? 4.5? 3.0? 5.9? 1.8? Okay. 2.2? 5.3? 2.1? 2.5? 4.1? Hopefully they match up. Yeah, they do. All right. Woo, baby. So we do that. There's all my dots. So you guys are smart. Do you think that's a really good data points?
Not really.
Yeah, it's pretty bad, isn't it? I mean, I'd say it probably has somewhat of a negative correlation to it. I mean, I think the points out here are saving it from going vertical. So, all right, how do I find my equation?
What is it?
Y1.
Y1, what's the squiggly line?
Tilde.
Tilde.
MX1.
X1 plus B.
Plus B. Cool. All right. So our least squares regression line, they say that's the line of best fit that works. Oh my gosh. Well, hey, you know what? You actually have this chair. You had no idea you had a comfy chair. Good to see that. Oh. Yeah, I rearranged the room and then I realized you didn't have a desk, so I gave you a coffee. Yeah. All right. So our least squares regression line, meaning if I made each one of these a square, this has the minimum amount of areas if I added them all up. So let's find the correlation. Oh, the correlation, negative 0.24. So it is a weak negative correlation. Agree? Our correlation is negative 0.24. So find the correlation, negative 0.24. Interpret the correlation in the context of this question. It is negative and it is weak. Does that make sense? Negative because the slope's negative as well. All right, find the equation of the regression line. Okay, so y equals negative 0.065 x plus 3.09.
Negative 0.065. What?
X plus 3.06. Predict the inflation with a GDP of 5.5 trillion. Okay, so if I wanted to figure out what 5.5 trillion would be, what I'm going to do is I'm going to go x equals 5.5. X equals 5.5. All right, so, hey, is that interpolation or extrapolation? Interpolation. It's inside our data. So we trust that. Extrapolation, we don't. So if you had a gross domestic product of 5.5 trillion, then you have a inflation rate of 2.73%. Okay.
Yeah.
Do we trust this prediction? Okay. Now, what did I show you yesterday as well to show if we trust the prediction or not? So right now, I think that R value is horrible. Agreed? So I don't know if I would trust it that much. But what was the next test I showed you yesterday? A little bit. Residual. Guys, if you hit that residuals plot, if you hit this residuals plot right here, those data points, I'm actually going to turn off this. Whoops. I meant to turn it off. I got to keep it on. Okay, so let me turn that off. Why isn't it turning off? I want it off. Let me turn that off. It's forcing us to have the line of best fit there. Okay, so let me change our dot color on this. Let's go very vibrant. Actually, let me turn those dots off. Okay, that makes it look easier. All right, so friends, is there a pattern? Those blue dots are the residual. Remember those blue dots, that's the distance above or below our actual line of best fit. But it's showing you in the representation above or below the x-axis. Friends, do you feel that there's some sort of pattern that's taking place up there?
Not really.
Is there more data points to the left than there is to the right?
Yeah.
So this is kind of a fan shape. It's doing this. Does that make sense? Is a fan shape a pattern? Well, it's a shape. It's a pattern. It's got to be. So, my friends, do we trust the predictions made by this? No, I don't. I have a fan-shaped residual plot, which is really bad, okay? Meaning I have more data to the left than to the right, so that shows that residual. And then we had an R value of negative point. I turned it off, so I don't remember what it was. I have the R value of negative 0.24. Friends, this is really, really bad. Like, don't trust this. This is horrible. Don't trust this at all. Our residuals show a fan pattern. Our R value is very low. It's like getting a 24% on a test. That stinks. That's bad. Okay? Find and interpret the slope of this regression line. This regression line, so this is the change in the y direction. So you lose 0.065 of your, I forgot what the title was. You lose that much percent of your inflation rate as you gain 1 trillion in gross domestic product. Because GDP was the X. Yeesh. Trying to interpret the y-intercept of this line. The y-intercept is 3.1 roughly. So if I have 0 inflation rate, then my GDP comes out to 3.086 trillion. What does that tell you about inflation on a really bad data map? Get that inflation down. You guys want to know why we have inflation? You guys want to know why the federal government spends so much money? I heard this many years ago from a teacher that I used to teach her. He put it this way. Have you ever borrowed your parents' credit card to go to the store? If so, did you ever buy a little bit extra because it's mom and dad's credit card? It's easy to spend someone else's money, isn't it? There's your federal government for you. They're spending all our money because it's not their money. It's easy to spend someone else's money. Yay. I thought that was a pretty good iteration of it. All right, so we're good up through 7. Flip the page.
Y1 tilde MX1 plus B. Yeah. You just plug in the M and D, and then you get your equation, which would be y equals negative
All right.
0.065x plus 3.09.
In this case, phrase low order means weak relationship. Explain what that means in the context. Okay. I'd say let's skip that one. I'm going to skip number 8, but I'm going to go to number 9. Oh, wait. There was something above. I didn't realize that. A study in Intermath research collected data and looked at a relationship between cholesterol level and systolic blood pressure. The resulting finding was that low order positive relationship existed. In this case, the phrase low order and weak relationship. I will never ask you that. I'm skipping it. I don't like it. I can say that because I wrote the test and it's not on the test. All right.
Something in there isn't right.
So they have this that resulted from the study. Y hat is a predicted systolic, cholesterol levels X. We have an R value that's positive, 0.18. Yikes. So predict the level if he has 206. Okay. So 206, I'm going to plug in for X. So you'd go 71.33333 plus 0.06486 times 206, and you get some number. So you're just plugging it in. Interpret the slope. Basically, your systolic blood pressure goes up by 0.06486 for each increase of 1 cholesterol level. Interpret the y-intercept. If you have 0 cholesterol, your systolic blood pressure is 71.33. Is it possible to have 0 cholesterol, friends? As soon as your little heart, when you're inside mama, started beating, you're putting cholesterol through your body. Kids can't get away from it. If your cholesterol level goes down by 20 points in the next year, predict the amount that your systolic blood pressure will go down. So if I go down 20 points, okay, if I go down 20 points, that's a negative 20, right? If you plug a negative 20 in there, do we have an original? Oh, actually, I'm going to do this. 206 minus 20, that's 186. Plug 186 in there, and that'll tell you that. Do you feel like changing your cholesterol level will directly result in a change to your blood pressure? Explain. Focus on this R value. This is pretty bad. I'm not trusting this stuff. I'm not changing my diet. Okay? Looking over this information, what do you take away from this research? Well, this medical research is clearly really bad. This would not even be accepted by the FDA. That R value is so low. Okay? If they went and tried to submit this publication and went to a journal of medicine, it would be laughed off the table. Okay? It's, don't accept it. All right. And then, almost done. There's only a few things I want to make sure we know. Okay. Response variable on this one, number 15. Response is the Y value, so that's weight. How many data points produce a response variable observations that are higher than the regression would predict? So I'm going to count all the dots above the lines. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at the data point with the highest value in the response variable. Draw in the segment that represents the residual. So like here, draw a vertical line. I don't know why. Estimate the residual for this data point. 140 minus 110, so roughly 30, positive 30 because it's above the line. Estimate the correlation. R value somewhere above 0.5, positive 0.5. And, okay, number 20, for star next number 20, is it possible for every scatter plot to exist in which every residual value is 0? Yes. Your data forms a perfect straight line. You have a residual of 0. What might a scatter plot look like in that situation? Your dots fall in an exact straight line. Is it possible for a residual to be positive? Yeah. If you're above your line of best fit with your data point, that is a positive residual. If it's below it, it's negative. So, my friends, I will be here at school tomorrow, but I won't be in this class. You have a quiz tomorrow in this class. During the quiz, you get to use everybody, all your notes, all that good stuff with the sub. Send me a text of the sub says something goofy. I'll come down and put the hammer down. Deal? So what time we out here?
Would you say for number 20 again? Huh?